On the 23rd of March, 1875, a British survey ship stopped in the middle of the Pacific and began lowering a rope. Hemp line, iron weights, paid out by hand over the rail. Normally, the weight struck bottom within the hour. This time, it kept going. 4,475 fathoms went over the side before it stopped. Over 5 miles. They had just underestimated the place by nearly 2 more.
The ship was HMS Challenger, 3 years into a voyage that would take 4. The figure her crew wrote down was 4,475 fathoms, 8,184 meters. It stood, more or less, for 76 years. Then, in 1951, a British vessel carrying the same name came back with echo sounding, bounced sound off the floor instead of dropping rope onto it, and found the bottom kilometers below where the rope had stopped. The place took the ship's name, Challenger Deep. What is genuinely odd is that we still argue about the number. Published depths cluster somewhere between roughly 10,900 and 10,935 meters, and the uncertainty on a sonar measurement at that range runs to tens of meters either way. When Victor Vescovo dived it in 2019 and announced the deepest descent ever made, James Cameron, who had gone down alone in 2012, publicly disagreed. Cameron's argument was that the floor there is flat and featureless, and there is nothing deeper to reach. 2 men who have both been to the bottom of the world cannot agree on how far down they went.
To understand the hole, you have to look at what is going into it. Along the Mariana Trench, the Pacific Plate, some of the oldest oceanic crust on Earth, at roughly 150 to 180 million years, is sliding beneath the smaller Mariana Plate. Old crust is cold crust, and cold rock is heavy rock. Instead of easing in at a shallow angle, this slab plunges almost vertically, and the hinge where it bends is retreating seaward, which stretches the plate behind it until the crust splits open in the back. Geologists treat this margin as the extreme case. Convergent boundaries that behave this way are literally called Mariana type. The trench itself runs about 2,550 kilometers long and only 69 wide, and it is empty enough to bend the sea. Take that much rock out of the crust and the local pull of gravity drops with it, so the ocean surface sags toward the gap. Satellite measurements put the dip at around 10 meters. The sea above the deepest place on Earth sits lower than the sea beside it. You cannot see it. It is there.
On the 23rd of January, 1960, 2 men climbed into a steel sphere slung beneath a tank of aviation gasoline and let go, Jacques Piccard and Don Walsh. The descent took just under 5 hours. At around 9,000 meters, a plexiglass window in the entry tunnel cracked with a bang that shook the whole hull, and they carried on down anyway. On the floor, the pressure outside was over 1,000 times what you are sitting in now, about 1,086 bar, close to 8 tons on every square inch of that sphere. They stayed 20 minutes, and Piccard reported seeing a flatfish, a sole lying on the sediment, watching them land. That claim has been fought over ever since. Most biologists never accepted it. The Danish zoologist Torben Wolff argued he had most likely seen an eyeless sea cucumber. Walsh, who did not see the animal himself, later said the landing threw up so much silt it was like looking into a bowl of milk, and admitted neither of them was a trained biologist. It matters far more than a footnote should.
Here is why it matters. Deep-sea fish have a chemistry problem. Pressure deforms the proteins inside their cells, and the countermeasure they use is a compound called trimethylamine N-oxide, TMAO, which props those proteins up. The deeper the fish, the more of it they carry. But the load cannot rise forever. Somewhere, the inside of the fish becomes as concentrated as the seawater outside, and the trick simply runs out. Researchers calculated where that happened before anyone went to look, between roughly 8,200 and 8,400 meters. Then the cameras arrived. The Mariana snailfish, formally described in 2017, a small translucent animal with unfinished-looking bones, lives around 8,000. In August 2022, A beta duander in the Izu Ogasawara Trench off Japan filmed a juvenile snailfish at 8,336 meters. Deeper than that, nothing, which means the bottom 2.5 kilometers of the Mariana Trench contains no fish at all. Not rare fish, none. Picard's soul, if it was a soul, was sitting well below the depth at which a spine appears able to hold itself together.
The honest caveat first, because it is the strongest argument against everything I just said. This is an absence, not a presence. A few dozen camera drops across a trench 2,500 kilometers long is thin evidence, and absence of evidence holds only until somebody films the exception. What makes it convincing is the order it happened in. The chemistry predicted the line before anyone had the cameras to test it. Below that line, life continues without a backbone. Drop bait to the floor of Challenger Deep, and within hours you are swarmed by Hirondelia gigas, a pale crustacean a few centimeters long. Its shell should not survive down there, because at that pressure calcium carbonate dissolves. In 2019, researchers worked out the workaround. The animal secretes gluconic acid, uses it to strip aluminum out of the seafloor clay, and in alkaline seawater that aluminum sets into a hydroxide gel that coats its body like a skin. Deeper still, life gives up on being many-celled. Xenophyophores, single cells that build shells out of sediment and grow to 10 centimeters, have been recorded at 10,641 meters.
The geology gets stranger than the biology. Along the landward wall of the trench sit at least 16 active mud volcanoes, some 50 kilometers across and rising 2.5 kilometers off the seafloor. And what they erupt is not lava. It is serpentinite mud, mantle rock chemically torn apart by water, squeezed out of the sinking slab far below. The fluid that comes up with it has been measured at pH 12.5. That is not acid, that is the other direction entirely, roughly the territory of oven cleaner, and there are archaea living in it. Move on to the volcanic arc alongside the trench, and it gets harder to believe. At the Daikoku Seamount, cameras in 2006 found a pool of molten sulfur, convecting slowly under a partly solidified crust, with gas bubbles pushing up through it and coating themselves in sulfur as they rose. The only other place we know of with a molten sulfur pool is Io, a moon of Jupiter. And at a vent field called Champagne on NWI Fuku, liquid carbon dioxide comes out of the seabed in droplets. For all of that, the most uncomfortable thing about the trench is how connected it turns out to be. In 2017, a team analyzed the fat of those amphipods and found PCBs, industrial chemicals banned decades ago, at concentrations around 50 times higher than crabs taken from one of the most polluted river systems in China. 2 years later, another group found carbon-14 from the atmospheric nuclear tests of the 1950s and 60s sitting in amphipod muscle tissue. Ocean circulation takes centuries to carry that water down. The food chain did it in years. And it is not silent. In 2015, NOAA lowered a titanium-cased hydrophone to the floor of Challenger Deep and left it recording for 23 days, expecting one of the quietest places on Earth. They got earthquakes, near and distant, baleen whales, ship propellers, air guns, a Category 4 typhoon passing overhead. One call in that region, 5 parts long and ending in a metallic ring, was nicknamed the Western Pacific Biotwang and stayed unexplained for years. It was first guessed to be a minke whale. In 2024, machine learning run over 200,000 hours of audio matched it to Bride's whales.
In 2009, the trench became a United States Marine National Monument, 95,000 square miles of seabed, almost none of it ever seen. You will still hear that fewer people have reached the bottom than have walked on the moon. That stopped being true around 2020. The deepest place on Earth is not unreachable now. It is just unvisited. We keep going back to places like this.